All right, so today we're going to continue looking at logs, looking at section 7.3. And the first thing we're going to look at is kind of some special patterns. There's no arithmetic, there's no calculation, there's no formula here. It's just like a special pattern that if you see this, you'll automatically know the answer. And I'll show you why. All right, so here's the first one. In an actual problem, the A's and M's would be numbers. So this is A raised to the power log base A of M. So it's exponential, but it's kind of weird because there's actually a logarithm up in the exponent, the word log. It's up in the exponent. So an example of something like that would look like this. 2 to the log base 2 of pi. Okay? The key here is that this and that match. This and that match. As long as those two things match, okay, don't do this in your notes because you need to see the formula. But as long as they match, what ends up happening is those cancel out, and the answer that you get is whatever is sitting right there. Those two things basically cancel out. Okay, but that only works if these two things are the same. Right, so we'll come through and do this problem in a second, but if you cross out what I just showed you cancels, there's only one thing you're left with, and that's basically the answer to the problem. And that's it, just a special pattern. Now, if you change this 2 to a 3, then that doesn't work. Okay, those numbers have to match. All right, let's look at the second one. So a little different formula. This is a log equation. How do I know? Well, I've got the word log, and I have a base, an argument, and the thing on the other side. So this says log base A of A to the R. Okay, kind of a similar thing happens if this and that match. Okay, like, I'll show you an example. Like in this problem, log base 0.2 of 0.2 to the negative 4. As long as these match, then the answer to the problem is whatever is sitting right there. So whatever you have right there is the answer to what all that would simplify to. Let's take a little bit closer look at this one. Just move all this stuff away. So I'm going to look at why this one is true. Okay, kind of explain it, I think, in a way that's pretty straightforward. Okay? So there's three things here. Okay? You've got your base, your argument, and then the thing that's on the other side. So I'm going to change this from a log equation, and I'm going to put it as an exponential equation next to it. And by doing that, I think you'll see why that formula is true. So my base is A. So I'm going to start with that. The base is A. Alan, we said yesterday that logarithms always equal the what kind of number?
Couldn't tell you.
You remember? The exponent. Very good, Michael. Exponent. So logarithms always equal the exponent. So we just use the base. We just use the exponent. Now, Lexi, what's the only thing that's left that I would have to put on the other side? The argument, right here. That's your argument, A to the R. Well, okay, what just happened? You had A to the R equals A to the R. So what this is saying is that rule 2, the kind of the fancy word for it is the reflexive property. Something equals itself. That's all. Right, you probably saw that property maybe in algebra or geometry. Okay, that something is always equal to itself. But that's rule 2. It's just written as a log, not the way you probably saw it back in geometry. Right, let's look at rule 3. This says that the log of 1 equals 0. Always. Doesn't matter what the base is. The log of 1 always equals 0. So what I'm going to do, I'm going to explain why this one is true, and I'm going to do it the same way I did the top one. I'm going to change it from a log equation to an exponential. And by doing that, it's going to turn it into a fact that I think you already know. So Ethan, what's my base here? A. Yep. So my base is A. So we've got that. Colby, what is my exponent on the A?
0.
Yep. There's my exponent. And now from algebra, if you raise anything to the 0 power, what do you always get? Right? 1. I mean, if you're not sure, you could always double check, but 5 to the 0, 9 to the 0. Doesn't matter what you raise to the 0 power, you always get 1. And look at what the argument is, 1. So rule 3 is just saying something you already know from algebra. Anything to the 0 power is 1. On the right is how you probably would see it in algebra 1. On the left is how you would write it as a log rule. And the last one. This says that the log base A of A equals 1. So if you're taking a log and your argument and your base match, the answer is 1. Okay, let's change that to exponential, and we can see why this one is true. Carissa, what's my base here?
A.
Yep, this one. Right, that's my lower one, so my base is A. Abby, what's my exponent?
1.
1. Put that there. And Caitlin, if you raise anything to the first power, does it change it? No. So raising A to the first power, you get itself back. Well, look at what's sitting right here. Just an A. All right. So that's what rule 4 is saying. If you take and raise something to the first power, you get the same thing back. On the right is how you'd see it in algebra 1. On the left, that's how you would write it as a log rule. Okay, so any questions on those special patterns? All right, so let's take a look at a few examples. All right, so let me put both on the screen at the same time, the best I can. All right, let's look at example A. All right, so looking at example A, which rule does that one look like it would fit into? 1, 2, 3, or 4? Chris?
1.
Yeah, it would fit into rule 1 because that's where you have a base, you have a logarithm up in the exponent, and the base and the base match. Base and the base match. So if we apply rule 1 to that problem, what should the answer be? Pi. The answer is whatever is sitting right there. Pi. Now, I didn't really go through and explain that particular rule. I could. It comes out very similar to rule 2. It's another. It's kind of like a reflexive property. Okay, but we don't have to go through that. Okay, second one. So this one I think I already kind of went through with you. But this is an example of rule 2. You have a base on the log, and the argument match. This matches that. Okay? When those two things match, the answer is whatever is up as your exponent. Okay? In this case, -4. And that's it. So it's just a special pattern to look for. Questions on the first two? All right, let's try this one. It says the ln of e to the kt. Now, if you look at it quickly, it doesn't look exactly like, oops, I pasted something. Doesn't look exactly like one of those rules, but there's something we could change that we talked about yesterday, and then it would look like one of those rules. Ethan?
Change the element to log base e.
Yeah, change this to log base e. Now copy the rest of it. E to the kt. What rule does that look like now? Yeah, right. Yeah, that's rule 2. You've got a base, and the base on the argument match. So Ryan, what would the answer be if you simplify that? K times t, whatever k and t are. K times t. Let's see, I didn't do one of the other rules. Let's do this one. Log base 5 of 5. Tanner, what rule is that one?
Rule 4.
Yeah, that's rule 4. So basically, another way to look at d is you can say 5 to what power gives you 5. Okay. What would be the answer to that, Tanner? 1. 5 to the first power is 5. Okay, I didn't do an example of rule 3, but any questions on how that one would be? Okay, so not too much you really have to do with that. You just look for a special pattern. All right, so the second thing we're going to look at are some properties to take logs that are separate and combine them. Or we can reverse it. We can take logs that are combined and we can split them apart. It works both ways. Okay, so here's our first property. This property has to do with a logarithm of a product. Okay, so inside the argument is a product of 2 letters, m times n. You can take the log of a product and you can split it as a sum. So product splits as a sum. Notice when you split it apart, whatever the base was on the original log, that's the base all the way through. The base started as a. When it's split, it stayed as a. The first argument is the first factor. The second argument is the second factor. And if you had a third argument, that would be the third factor. So you can split it up into as many as you need to. If you're multiplying 2 things, it splits into 2 things that are added. If you're multiplying 3 things, it would split into 3 things that are added. 20 things, 20 things that are added. And each argument just comes from each factor. All right, so here's an example of that with numbers. If you took the log of 20 and think of 20 as 4 times 5. Okay, I need to think of 20 as a product in order for this to work. So if you take the log of 20, and I'm just doing base 10. Okay? This could work with any base you want me to use. Base 10, base e, but the calculator can do base 10, so it's easy for me to show you quickly. So there's the log of 20. Now if I take the log of 4 plus the log of 5, I get exactly the same thing. What's another way to break up 20 instead of 4 times 5? 10 times 2. So you could also do log 10 plus log 2. Any 2 numbers that multiply to give you 20, if you split it up like that, will work. You could do 40 and 1/2. 40 times 1/2 is 20. Okay. So any questions on that first rule? We're going to practice it each way. I'll give you some that are combined, and I'm going to ask you to split it. And then I'll give you some that are split and ask you to recombine it. Okay. All right, so second rule. This time, instead of multiplication inside the argument, it's division. Did anyone have a guess on how division is going to split apart? It's going to split into 2 things, but it's not going to be addition this time. Yeah, it's going to be subtraction. So if you have the log of a fraction, and you want to split it, fraction splits as a difference. Whatever the base was to start with, keep the base the same all the way through. And it's log of the top minus log of the bottom. Now with subtraction, is it important you do it in the right order, or can you switch the order and get the same thing? You got to do it in the right order. Okay. With addition, it's not as important. Just think of like 2 plus 7, 7 plus 2, same thing. But change it to subtraction, the order becomes important. All right. Now let's take a look at our third rule. Right. There's an example with numbers. I'm not going to type it in, but if you want to check it on the calculator, you can check it. It does work. All right, so the third rule is kind of like rule 1, except instead of multiplying different things together, it's the same thing, like m times m, or x times x, or even more, like y times y times y times y. Okay, it's repeated multiplication of the same thing. All right, so before I write it, let's look at something like this. Log of x cubed. Okay, remember, exponent means repeated multiplication of the same thing. So that's log of x times x times x. Now, let's split that apart the way we just learned to split a product. Okay. Does a product split as a sum or a difference? Sum. And in this case, we have 1, 2, 3 things. So I'm going to have 3 logs. Now, I didn't put a base on the log, so because I didn't put one, what base am I assuming? 10. Okay. What I'm about to show you could work for any base. 10, base 5, base 6, base 2, whatever base you want to use. But I'm just trying to show you a pattern. The base isn't really important. My first argument is my first factor. Second argument is the second factor. Third argument, it's my third factor. And we just said they split as a sum. So I have the log of x plus the log of x plus the log of x. How many log of x's do I have? About Luke?
3.
3. I have 3 of the log x's. Now, I want you to look at this. Look at this. And from now on, there's a shortcut we can use to get from the top box to the bottom box. Does anybody see what you would have to do to what's in the top box to make it look like what's in the bottom? Cassandra?
Move the exponent to the front of the log.
Yeah, and that's the third rule that I'm going to write down. You are allowed to take exponents on arguments and put them in front. And that's the reason why. So here we have an exponent of r on the argument. And I'm going to take the r and put it in front. And here's another example with numbers. So log base 10 of 3 to the 5th is exactly the same as 5 in front of all of that. 5 log base 10 of 3.
Can you just move up just a little bit? That's okay.
Yes, I can.
Thank you.
Okay, so any question on that? So those are the 3 basic rules that we can use to combine logarithms together. The last one isn't really combining logarithms, it's just moving an exponent in front. But that's a rule they throw in here with the other 2. All right, so one more thing that will come up from algebra is anytime you have a square root, technically a square root is hiding an exponent. Just like when I don't write a base on a log, the exponent is there, it's just hidden, it's a 10. Well, square root of x means a 1/2 exponent. And if you don't remember that, just try an example, like take the square root of 16. Okay, you get 4. Now take 16 to the 1/2 exponent. You get exactly the same thing, 4. So taking a square root, raising to a 1/2 power means the same thing. Right? So that'll come up a little bit when we look at rule 3, because we're going to have to take an exponent and move it in front. Okay. All right, so let's look at a few examples. Okay, so the directions here say to write as a sum or difference. So what it's basically asking you to do is split it apart. And it says express powers as factors. That's the exact wording you're going to see on the test. Express powers as factors means do rule 3. Don't leave things as exponents. Don't leave powers. Put powers in front. I'm not going to spell it out for you that way on the test. I'm going to write it like this. Express powers as factors. All right, so we'll start with this one. Jordan, would this log split as a sum or difference?
Sum.
Yeah, it's a sum because you have multiplication inside the argument. So we're going to have 2 logs. We're going to have a sum. Lauren, what's going to be the base on each log? 4. The base stays exactly the same all the way through the problem. Sam, what's going to be my first argument?
3.
Yep, my first argument is my first factor. And Colby, my second argument? X. And that's it. So you're not solving for x here. It's not like you're getting x equals 5 and solving an equation. All you're doing is rewriting something. You don't even have an equation. Any questions on that? All right, so let's try this one. Log base 2 of 5r cubed. And so Luke, inside my argument, do I have multiplication or division? Multiplication. Might be, one of the things might be a little bit more complicated in the last problem, but overall I have something times something. That's exactly what I had here. Something times something. All right, so when we have a product, split it as addition. Log. Jermichael, what's going to be the base on each log?
2.
2, yep. Base stays the same. Carissa, my first argument will be 5. And now there's nothing else you can do with that. We're just going to leave it. And Liz, what about my second argument? How do you say r cubed? Or r to the 3rd. Now, the directions said to express all exponents as factors, which means you can't technically leave it like that. So I need to do one thing with the second part, and I'm just going to erase it so I don't have to rewrite it. Yeah? You have to put the 3 in front. If you want to rewrite it as a whole separate step, you can. But the directions said to put the 3 in front. And that's it. Questions on it? Okay, so again, you are not solving for anything. All you're doing is taking something they gave you and you're writing it in a different way. That's all. All right, let's look at this one. Log base 9 of x divided by 2. All right, so Emma, this time when we split it into two logs, addition or subtraction?
Subtraction.
Right, this time it's going to be subtraction because we're dividing instead of multiplying. So we've got log minus another log. Justin, what's going to be my base on each log? You just copy down whatever the base was to start. 9. 9. Then what about my first argument?
X.
Yep, first argument is the numerator. And Austin, my second argument? 2. And that's it. Any questions on that? Okay, we're starting out with ones that they don't have a lot in them. They're pretty much, you can do them in one step. The problem before was technically 2 steps, but we'll get to some ones that have more steps in them. Okay, let's look at this one. So I said to you, these rules apply to any base. In the last problem, we did base 9. The problem before that was base 2. And before that, we did base 4. What base am I doing in example D? Even though it's not written, it's hidden. Yep.
E.
I'm doing base E. You don't have to write it that way. You're going to leave it as ln. I know ln means log base E. We'll write it the short way. Okay. Anyone think they can tell me what that one would be, like the whole thing, the final answer? Joe?
3 ln y minus ln.
No. Exactly. So it splits as a difference. And you would have ln y cubed. But then the cube has to go, the 3 has to go in front. And that's it. Questions on the one? All right, I have a bunch of these. Let's just jump to this one. All right, so this is probably the hardest one I could kind of give you. It's got everything in it. But it's still just going to use those 3 basic rules. We just look at it one step at a time. Now, anytime you have a problem that has both division and multiplication in it, and if you're like, wait, what is he talking about? There's the division. Okay. We're going to handle that first. Okay. Always do the division first, which is rule 2. So we're going to split it into 2 logs. This time the base is unknown. It's an A. Doesn't matter. Just copy it down. It's going to be a difference. The top is going to be my first argument. So log of the top minus log of the bottom. So it's x cubed times x plus 1 to the 4th. Now I put that big set of parentheses on the right side just to let people know that this whole thing is part of the argument. Okay, if you didn't put that and you wrote it like this, somebody looking at that might not be sure, well, is it just the log of x cubed and the x plus 1 isn't part of the log? It's not like a square root symbol where you can tell. Like if I do this, that's super clear that the x cubed and the x plus 1 are all part of the square root because they're under the symbol. With a log, you don't have a line like that to tell you. So you put a set of parentheses to say, hey, everything that's in these parentheses, that's all part of the log. All right. So let's look at the first part, because this has something in it we talked about. That square root is hiding an exponent. So the direction said to express all products or exponents as factors. If you forget that the square root is hiding an exponent and you leave the square root in the final answer, it's wrong. Okay. So what exponent is the square root hiding? Yeah? Yeah, Glenn?
It's not a half.
It's hiding a 1/2 exponent. So let's make it obvious that it's there. Instead of saying, I'm going to take the square root of x squared plus 1, I'm going to raise it to the 1/2 power. It's exactly the same thing, but now it's obvious and I won't forget, okay, when I'm done, put the 1/2 in front. Okay, and once we move the 1/2 in front, the first part is done. There's nothing else you can do with it. We don't have a rule for a sum. We had a rule for a product. We had a rule for a fraction. There is no rule when your argument is a sum. Yeah.
So why is it half?
Why?
Yeah.
Just because from algebra, when you take a square root, square roots always are to the 1/2 power. It's just another way of writing a square root. Like if you didn't want to write cube root, you could put to the 1/3 power. Fifth root, 1/5 power. It's just how roots work in algebra. All right, now let's look at the second part. Yeah?
So that x squared, that exponent doesn't matter?
No, that exponent's fine because that's inside an argument with a sum, so we just leave it. Yeah. If there wasn't a +1 here, then yes, I would have to do something with that. Yeah, but then I have a totally different rule from algebra. That's a power to a power, which now we can multiply exponents. Like if you remember this from algebra, x cubed to the 4th is x to the 12th. That's what would be going on there. Okay, but we don't have that this time. Okay. Whenever you have a sum or a difference added to something with a power, you just leave it. All right, so the second part. All right, looking at the second part, I have multiplication. I don't need to put that dot in there. It's understood if it's not there, but it's x cubed times x plus 1 to the 4th. Sean, how is multiplication going to split? We have to split this apart because we have something times something. When you split apart two things that are multiplied, how does it split?
By adding.
By adding. All right? Now, we have to be careful when we split it. Bless you. Because however you split it, you are subtracting whatever you split it into. All right. So what I want to do to make sure we remember is we're going to put a set of parentheses. And we're going to split it into 2 logs, exactly the way Sean said, as a sum. But remember, when you split it, you are subtracting the entire thing you're splitting. So it's almost like that negative would be distributed. Okay. So any questions why I put parentheses around that? It's kind of like if I had 5 minus 6, and I said to you, okay, I want you to split up the number 6. Well, you have to do it like this. 3 plus 3. Or you could have done 5 plus 1. You could do it different ways. But you have to keep parentheses around that. So you distribute your minus sign. Okay? If you don't put parentheses, then it's wrong. All right. So my first argument is x cubed. My second argument is x plus 1 to the 4th. Now, the last thing I have to do, and I have to do it in 3 separate spots, is what? What do I have to do with all those exponents? Yep.
Put them in the front.
Put them in the front of their respective logs. So put the 1/2 in front. Okay, and again, we already talked about why we can't move the 2, because it has a sum. You can't touch it if there's something added to it or subtracted. You just have to leave it. Minus. Now we put the 3 in front. And lastly, put the 4 in front. And that's about as bad as it can get. And even the worst problem I can give you, it still was only 3 steps. It's not like the worst problem is like 100 steps. Three steps. Okay, so always deal with your fraction first. And then if you have the other things to deal with, like a product, deal with that second. Any questions on that? If this were a multiple choice problem, I would probably list that as a choice, the second one. And that is wrong, okay? Because the direction specifically said, put those exponents in front. So if you picked that as a choice, you only went like 3/4 of the way through the problem. You didn't finish putting the exponents in front, okay? And the other thing that will trip people up on the test is the square root. People will forget square root is a 1/2 exponent. Guaranteed. Okay, so don't forget that. All right. So now, I think splitting them apart is harder than combining them, because when you're splitting, it's getting more and more complicated each time. So you're starting with something nice and small, and you're making it bigger and bigger and bigger as you go. Well, now we're going to condense it. And you do everything exactly the way we just did in reverse. So if you think about the last thing we just did in the problem before this, that's going to be the first thing you do here in reverse. So anyone think they could tell me what the first thing you would do on this problem is? Yeah?
Move the exponents to, like, move the 4 to, like, be an exponent.
Yeah.
2, 3.
Put the 4 back as an exponent. Okay? Do it in reverse. So now you have log base a of 7 plus log base a of 3 to the 4th. Okay. 3 to the 4th, we can do that out. 3 times 3 times 3 times 3 gives me 81. All right. Now, next step, I have a sum. If I want to recombine that into a single log, I know the base stays the same. The base never changes. If something's split as a sum, what must it have been originally? Yeah. Multiplication. Must have been multiplication. So this must have been 7 times 81. And we don't leave it as 7 times 81. We just finish that off because we do have all numbers here. So log base a of 567. I'm not going to do as many recombining, because if you can do splitting, combining is just everything in reverse. But I'll do 2 more, and then we're going to finish up with something on the calculator. Okay. Question on 3A. Let's look at this one. 2 log base 3 of u minus log base 3 v. Now, on some of these problems, you might see some direction. You might see something a little extra added to it in the book. You might see something like u is greater than 0 and v is greater than 0. That doesn't really affect how you do the problem at all. All they're telling you is that these 2 things are positive. If they weren't, you would have imaginary numbers here. All right. So u and v, they're just guaranteeing you they will be positive numbers. Don't worry about them being negative. Okay. But again, that has no effect on how you would do anything at all. All right, let's see if we can do this one all in one step. How about Brianna? When I recombine it into one log, what's going to be my base? The 3. So it's going to be a base 3. And Kyle, since I have a subtraction here, what must that have been before we split it?
I have no idea.
Think about, you have 2 choices. Either this came from a multiplication problem, or it came from a division problem.
Division.
Division, yes. Okay. If you look at the last one, we had multiplication, and that came from a sum. This is going to be division because it comes from a difference. Okay. Pacey, could you tell me in my fraction what would go in the top?
I have no clue.
All right. What's the first thing? Somebody help him out. What's the first thing you have to do here? Maybe we shouldn't have done this in one step, but I'm not sure. Yep.
Put the exponent back where it belongs.
Put the exponent back where it goes, right there. So that tells you what's in the top is u squared. And now the bottom, there's nothing you have to move back in front. So the bottom of my fraction would just be, yeah, v. And that's it. So log base 3 of u squared over v. Any questions on that one? All right, so let's look at, let's jump right to the hardest kind of problem you can have. And it's going to look like it's a lot, but we're going to be able to do it, well, just as easy or hard as we did the last one. Let's see. Does anyone want to see one with ln? Or no? It would be the same thing. The only thing is, I wouldn't leave this like that. Why leave that as 3 to the 4th minus 8? 3 to the 4th is 81. We just did that. So simplify this as 81 minus 8. Might as well do that out first. All right, so let's look at this one. So we got 4 things. 1, 2, 3, 4. When I recombine that into a single log, Carissa, what's going to be my base?
A.
A. So it's going to be log base A. Now look at the first 3. Something plus something plus something. How do we recombine logs when they're plus? Yep. Multiplication. So it's going to be this times that times that. So I'm going to do it a little out of order because it's how we would write it. 9 times x. Start with that. 9 times x squared plus 1. That's how you recombine all of that. Now the last one is a minus. We just said minus means divide. What are we going to divide everything by? What would go in the bottom right here? 5. And that's it. So at first it looks like it might be kind of a hard problem, but it really isn't that bad.
How come 5 is a bonus?
Because 5 is subtracted, and anytime you have subtraction, subtraction means divide. Yep. Everything else went in the top because it was times, 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 and then the last one was a divide. Okay, any questions on that? As far as recombining, that's as bad as it could really get. All right, so let's look at the last thing, which is on the calculator. And it's called the change of base formula. Okay. What this formula allows us to do is type in any base that you want into the calculator. Now, without this formula, there's only 2 bases you can type in right now. Can someone remind me, what's one of the bases that we can press a button for on the calculator? Yep.
Log of 10.
So base 10. Yep. And base E. Okay. Those 2 buttons are on my calculator, right next to the 7 and next to the 4. All right, so I'm going to go through and show you where the formula comes from to type in other bases. All right, so there's a problem I could ask you to do. Pretend a and x were numbers. Log base 5 of 12. That doesn't fit any of the special patterns I gave you at the beginning of class. It's not like it's log base 5 of 5. If that was the case, that's a special pattern. But it's not a special pattern, and the base is not a 10, and it's not an 8. So how would you get the answer to that? Okay, so let's take a look at this. Right now, I have a formula, and it's equal to y. What's in that red box is equal to y. Okay, remember that. Because we're going to get a different formula equal to y in a second. So I'm going to show you a different way to rewrite this, a way that you can type in on the calculator. Okay, let's start by changing it to exponential form. Tanner, what's my base here? A. And my exponent?
X. Y.
Y. Logarithm always equals the exponent. Argument ends up by itself. Questions on that? Now, I'm going to do something we haven't done before, but you can do it as long as you do it on both sides, just like anything. You've got to do it on both sides. I'm going to take the log of each side. You can take square roots of each side. You can add 5 to each side. Well, you can also take the log of each side. So take the log of what's on the left. And you know what? I'll write it on a new line so it's not as confusing. So the log of what's on the left equals the log of what's on the right. So now you might be looking at it like, oh wait, you just changed it to exponential form to get rid of the log. Now we just put the log back in. Well, you're going to see what happens in a second. Now I have an argument with an exponent. What am I allowed to do with that y? Because it's an exponent inside a log. Yep.
Move to the front.
I can move it to the front. So remember, my whole goal now is I'm trying to get y by itself again. It was already by itself, but the formula it was equal to, I don't know how to type that red box into the calculator. I'm trying to come up with a different formula for y that I can type in. So put the y in front. Now, something I've kind of mentioned all along, but I haven't mentioned it in this problem. I said take the log of each side. I didn't put a base on it. So what base did I assume I'm using here? 10. And that's the key. I assume base 10. And base 10 is something there is a button for on the calculator. So that's going to help us get in the right direction. All right. Now the last step. You have y times something. If you want to move something that's multiplied to the other side, what operation do you use? Yep. Division. So I'm going to divide by the log of a. And again, that would just be a number, like log of 6, whatever it is. And divide by log of a. And now look what happened. Y is by itself again. I get y equals, and I'm going to spell it out very clearly, even though I don't have to write this. Log base 10 of x over log base 10 of a. So I have a new formula for y, which is what I had originally. But now I've rewritten the formula in a way that I have a button for base 10. So now I could type something like that into the calculator. So if you wanted to know what log base 5 of 12 is, let's just take this and put it next to it so it's easier to see. Log base 5 of 12. You take log 12, log of x, put that in the top, and then log, I said base 5. Log 5 goes in the bottom. So the way you would type it in, log 12 over log 5. That's how you would type in something like that. Log of the argument divided by log of the base. Okay, and we'll practice typing one in a second. So this has to go in the top. Base goes in the bottom. Try to think of it that way. Base, bottom. Now, when I did this, I took the common log of each side. It turns out that you can do it with common log, or you could do it with natural log. It doesn't matter which way you do it. But I would just pick one of these two ways to remember, because they're the same thing. I did it this way. But you could also do it the bottom way. Okay, so that's our first problem. Log base 5 of 12. So take the log of the argument and divide by the log of the base. Okay, you do have to make sure you close your parentheses in the right spot. Okay, so log 12, close your parenthesis because now you're done with the top log, divided by, and now you've got a new log, and then close parentheses because you're done with that. So the answer is about 1.54. Now, let's say you said, well, ln is the same thing. Yeah, it's the same thing. ln of 12 divided by ln of 5. You have to actually put divided by. So 1.54, 1.54. You get the same thing either way. Okay? I usually do it the top way. That's how I do it. Questions on that? And now you can type in a log of whatever base you want. So let's try a base 3 log. Jordan, do I have a button on the calculator, or just a single button that I can press that does base 3?
I don't know.
Okay. Can someone remind him what are the buttons we have? One of them can do base, yep, E, and the other one can do base 10. We don't have a button for base 3. So now we have to start thinking, all right, how do I type in base 3? Change a base formula, okay, the way we just went through. So can somebody tell me how I would rewrite log base 3 of 16 so I can type it in? Yep.
Do log 16 over log 3.
Yep, that's it. Log 16 over log 3. Log 16 divided by log 3. So the answer is 2.52. If you forget to close your parenthesis between the 16 and the division sign, you won't get an error. You will get a number, but you will get the wrong number. So you might say, oh, it's 1.52. No, you forgot to close your parenthesis. So make sure you type it in exactly the way I'm showing you right there. Okay, so any questions on that? All right, so to kind of summarize 3 things we looked at. We started with the formulas that had the special pattern. Then we looked at how to split logs and combine them. And the last thing we did was to change a base formula. So homework tonight, some even, some odd, just copy it carefully. So it's 7 to 15 odd, 31 to 33 all, and then 39, 40, 51, 52, and 65 to 69 odd. Okay, so tomorrow we'll look at section 7.4. And section 7.4 is on solving equations. At this point, I've taught you everything you need to know to do section 7.4. There's no new formulas tomorrow. Okay. What will come up tomorrow that you might not remember as well is factoring. That's going to come up, and quadratic formula.